After World War II, short takeoff and landing, STOL, technology played a significant role in Western countries. All countries hoped to obtain a reliable performance STOL aircraft. Major technological countries such as the UK and the US have successively carried out various technical explorations, including a variety of STOL/vertical takeoff and landing, VTOL, technologies. One of the achievements is the well-known Harrier fighter jet. However, today we want to introduce another experimental aircraft, the Nord 500, which is a series of experimental aircraft developed by France in the 1960s. The Nord 500 is similar in technology to the American Bell X-22A, mainly used to verify the tilt duct fan technology, which contributes to the development of VTOL/STOL technology. The first prototype was completed in early 1967, mainly for mechanical testing and ground experiments. The second prototype capable of flying first took off in July of the following year, but many of the related flight tests were not completed, and many technical performance data were still only theoretical. The aircraft has a lightweight helicopter-like fuselage with a single-seat cockpit with a large windshield, providing excellent visibility for the pilot. It is equipped with short wings at the rear top of the fuselage, and duct fans with adjustable vanes are installed at both ends of the short wings. A slightly chubby horizontal tail is installed at the rear of the aircraft. The engine air intakes are located in the connection belt between the fuselage and the short wings, with two 317 horsepower Allison T63 turboshaft engines installed at the rear. The power of the side-by-side engines is transmitted to the duct propellers at the ends of the short wings through an interconnecting shaft. Part of the short wings and the duct propellers are fixed together and can be deflected together under the control of the pilot. Inside the duct is a set of 5-blade propellers. The duct propeller has two operating modes. In the vertical position, it can provide lift for the aircraft. At the end of the duct, there is a flow deflection small wing, which allows the pilot to control the deflection of the airflow, enabling the aircraft to fly at low speeds. Due to its structural characteristics, it is theoretically not difficult for the aircraft to perform maneuvers similar to a helicopter, such as turning in place or flying in reverse. This mode is mainly used for takeoff and landing. After reaching a certain altitude, the duct is deflected backward to produce rearward thrust, and the aircraft's flight attitude control is then completed by conventional tail structures. The Nord 500 has several conceptual derivative versions for civilian use, including two light aircraft. One is a light aircraft with an appropriately enlarged fuselage, capable of carrying 5 people including the pilot, and the other is the larger Nord 501, capable of carrying 8 passengers or transporting 5 tons of cargo. There is also a heavy aircraft capable of transporting 40 passengers or 10 tons of cargo. There are also many military versions. After the maturity of the prototype, a light reconnaissance aircraft was planned to be built, which would use more powerful engines and achieve a maximum flying speed of 380 km per hour, with plans to develop it into an air ambulance. The armed version, Nord 501, is similar to an armed helicopter, and is expected to use a 2,100 horsepower powerful engine to achieve a maximum flying speed of 600 km per hour. It is equipped with a turret similar to that of the AH-1 Cobra armed helicopter under the nose of the aircraft. The main mission of this aircraft is armed reconnaissance. Another powerful version is the attack aircraft, which has tandem cockpits and a dedicated weapons officer like an armed helicopter. In addition to the turret under the nose of the aircraft, there are weapon pylons under the fuselage and short wings for carrying air-to-air missiles, air-to-ground missiles, and other weapons. None of these follow-up models were realized, as the Nord 500 prototype itself did not reach maturity. The second prototype only underwent wind tunnel testing, stability simulation, and other tests, and did not even complete a proper autonomous flight. The project was terminated in 1971. The Nord 500 experimental aircraft faced many problems at the time, with the biggest difficulty being inadequate flight control technology. Compared to the more mature Harrier fighter jet of the same period, the aircraft represented the highest level of practical VTOL technology at the time, and it experienced numerous accidents during its service. It is believed that the flight control technology of France was not up to par. The Nord 500 experimental aircraft is approximately 6.6 meters long, 6.1 meters wide, and approximately 3.1 meters high, with an outer diameter of the duct of 2.08 meters and an inner diameter of 1.58 meters. The maximum takeoff weight of the aircraft is 1,250 kilograms, with a projected maximum flying speed of 350 kilometers per hour and a cruising speed of 282 kilometers per hour. The crew consists of one person.